attendees. Let me get our sharing started here. I'm just going to start with some introductory slides, and then Amitendra will get into the sample lesson. So, hold on a second. All right. Thank you for your patience. We're going to do a free sample class today from the AI and Machine Learning Bootcamp from Caltech Center for Technology and Management Education. And this will cover the topic of classification methods in machine learning. And Amitendra, who will give himself a better introduction in a short while when he starts his lesson. But he's extremely experienced. And he now reminds me he has more than 4,500 hours of experience in training. Is that correct? And
that's
also,
correct, Stuart.
And has delivered training on many ML and AI concepts. So this will be a great example of the kind of instruction you get. I'm going to start by introducing the curriculum just for a moment so you see where this lies in the overall program. And then the live lesson, and we'll do a Q&A, and I'll mention a little bit about the Caltech Bootcamp at the very end. The curriculum for the Caltech AI and ML Bootcamp starts off with an induction session, orientation session. Then you go into the basics of artificial intelligence, basic underlying concepts, and move into Python training, then learn how to apply Python in data science. And then in machine learning, which is the module from which this sample lesson's taken, you learn about the algorithms and methodologies for models to be able to adapt to new data that comes in. Then a module on deep learning, tools, Keras, and TensorFlow, and advanced deep learning and machine vision. And then a capstone project, and you then earn your certificate. Capstone project ties together everything you've learned in the program so that it is something you can show off to employers or potential employers. Along the way, you can take the electives also on statistics essentials, NLP, natural language processing and speech recognition, reinforcement learning, and master classes from Caltech instructors, so that they'll share topics in AI and ML with you. All of those are included in the program. So I'm going to let Amitendra discuss these next two slides before he shares his screen.
Thanks, Stuart. So hello, everyone. Amitendra here. I'm going to just explain you about classification methods. When we talk about machine learning, under machine learning, we have something called supervised learning, where we have such data sets where the input has been given and the corresponding output has also been given, and that's called supervised learning. And under supervised learning, there is a method called classification method, and this method basically helps you in terms of classifying the data into one of the categories. To give you a little perspective on that, suppose you work for a bank and you are into lending business, and you want to understand if a loan has to be given to a particular customer or not. So there's a way of looking at it. You should look for the bank balances, you should look for the transactional records, any loan that they have taken in the past, any kind of EMI which got bounced, any check got bounced, and then combining all these inputs, you come to a conclusion where you should give loan to a particular customer or not, because it might result into a bad debt. So classification technique helps you in terms of taking these inputs and classifying customers into one of the class, whether they will default on a loan or not. So that's where classification comes. And if you look into it, it's the same analysis I can take into HR domain, and I can think of among all the employees who are working, who will resign from the company, that I can term it as attrition analysis. So that again is a classification technique. Or it could be you want to understand if a transaction is fraudulent or not, and you want to use a machine learning algorithm to automate this entire process of identifying a fraudulent transaction so that customers do not lose their money. So whenever you have such kind of problem where your output requires one of the class to be predicted, we do classification. And there are different types of classification algorithms which are there. We have multi-class, binary classification. Binary classification is basically when you have only two classes, yes or no, success or failure. Multi-class could be where you are predicting an outcome which has more than two classes. And for this classification technique, there are a set of algorithms which are available. Some algorithms might work for a particular problem, some might not. So what we do over there, we try different algorithms, at least 2-3 we try on the data, we see which one is working well, and then we get on with that particular model in terms of fine-tuning it. One of the model that is mentioned over here is naive-Bayes, another is decision tree, random forest, logistic regression, Kane, and these are all example of classification algorithm. So idea is this, that you understand these algorithms and then you are able to implement on the data. That's what the whole idea is.
Okay.
And yes, Stuart.
I was going to say that so that covers our introductory slide. So at any time you want to start sharing your screen, please go ahead, Amitendra.
Sure. So I'll share now. So I'm going to give you an overview of what we are doing over here. I'm going to explain you classification. One of the model I'm picking up, I'm going to explain you the concept, and then we'll quickly implement on the data. And for that, I'm using our LMS. On our LMS, we have our lab. So once I log into my LMS, which will be given to you guys also, I go to my lab, I start my lab. I have my classification presentation with me, which is generally shared with participants as well. And this is what we are discussing here. So this is our lab. Here we will learn and we will implement. So both the stuff will happen simultaneously. And I was talking about some of the classification technique we discussed about. I just explained to you that there are multiple algorithms. One of them is naive-Bayes theorem, which is pretty interesting. We'll discuss about that. Another algorithm that you should learn is support vector machines along with your tree-based model, decision tree, random forest, or it could be boosting algorithms like a gradient boosting algorithm, extreme gradient boosting. And there might be certain libraries also which will make your job easier. One of the library which is pretty useful for boosting algorithm is called cat boost. So those are the algorithm that you should actually learn. Now, when you talk about classifier, I explained to you, the idea is this, that you have been given classes, like you might have certain people who have defaulted on a loan, some people who have not defaulted on a loan. And what you want to do is you want to build a classifier, and you can say that, okay, anyone who is above this line will default on a loan. Circle represents defaulters, and anyone who is below the line will not default on a loan. Those are the people who are regular customer, and they are pretty good. And I might have features like, say, age of the person, and I might have here annual income that they maintain, something like that. And the idea is to come up with this classifier. And there are different types of classifier. There could be a linear classifier, there could be a non-linear classifier. One of the classifier that we are discussing over here is called naive-Bayes classifier, which is based on naive-Bayes theorem. And the naive-Bayes theorem is a conditional probability that we talk about. And Bayes' theorem states this. This is based on a conditional probability, which kind of looks like a little complex, but I'll simplify it for you. So it says here, probability of an event A given B has taken place is given as this particular formula over here, which is probability of B given A, which is also termed as likelihoods. Then probability of A, which is called class prior probability. Then probability of B is called predictor prior probability, which is this. Now, in case if you're wondering what this probability is all about and what kind of problem we are solving here, let me give you a couple of examples and then probably it will be entirely clear to you. So what we are doing over here is, if I take an example over here, if suppose I receive thousands of emails, and out of 1,000 emails, I know 600 of them are regular email and 400 of them are spam. This is how I have got my data sorted. Once we received the emails, we manually classified them into regular emails and spam. And I got to know out of 1,000 emails that I have in my inbox, 600 are regular, 400 are spam. And now what happens is that tomorrow, suppose a new email comes, which has a word called free in it. And I want to know if this email that I have received, which has one of the word, it will have multiple words, but I'm just focusing on one word. If it has a word free in it, will it be a spam email or can I classify that as a regular email? And that's where this new Bayes theorem is coming into the picture. What we can do with this theorem, I'm just expanding the theorem that I have just shown you the formula. It says, what is the probability that the given email is a spam email provided a word free has occurred in it? That's what we do over here. We calculate a probability. What is the probability that a given email is a spam email? Already free has occurred in that particular email. So this is what we are calculating over here. And that's the same formula that I have spoken about earlier. P of A provided B has taken place. And this is given equal to probability of free happening in any of the spam emails. So now what I do, I go back to my database and I say, of all the spams that I got, 400 of them, calculate the total number of words that I have, total number of words that I have, total number of unique words in my spam, need not to be unique, total number of words in my spam emails, and how many times free is occurring in that particular spam set of data. And this is called likelihood, which is coming into the later, this second part of the equation over here. This is your how many times free is happening in all the spam emails that we have got. That's what we are calculating. That's called likelihood. And then we multiply this with what is the probability that any email would be spam. So same formula, we are just expanding. And then I can calculate what is the probability that the given email is a spam email. And with the same logic, I can also calculate what is the probability that the given email is a regular email, provided a word free has already taken place. And once we calculate these two probability using our conditional probability theorem given by Bayes, I can check which probability is higher, and whichever probability is higher, suppose I got here 0.4 and I got here 0.6, then I'll classify this email as a spam email. And that's pretty much what the working of Bayes is. So the formula looks a little complicated, but it is pretty simple actually. All we are doing here is we are calculating probabilities, and based on that, we are assigning a class. So this is how Bayes work in general. Okay, and to give you an example over here, just to finish it off, if I say that I have total 600 emails which are regular, 400 emails which are spam, and the word free is occurring 100 times in all the spams that we have got, all the spam emails. I have free happening 100 times, and total number of words are suppose 500. And similarly, if I talk about a regular email that has free happening 50 times out of 1,000 words, and I can calculate simply probability like this. What is the probability? This is spam, given the word free is there, is equal to 100 times free is happening in spam out of 500 words into probability of any email being spam, which is 400 upon 1,000, and keep continuing calculating it, and it will give you what is the probability that any email would be spam. And that's what Neo Bayes does actually. So Neo Bayes algorithm is pretty useful when you have a text classification that you want to do. For example, you want to do sentiment analysis. You have received thousands of reviews, and you want to know if a particular review should be tagged as a positive sentiment or negative sentiment, which is very essential. Understand this way, I might have thousands of feedbacks coming for a particular product. And overall, I want to understand that if my customers are really happy with the product or the feature or not, I can think of building a model which can analyze the entire data, comes up and tells me how many of them carries positive sentiment, how many of them carries negative sentiment, and eventually it also tells me among all the positive sentiment reviews that I have received, what are the keywords that has been used over there, what product features have been mentioned multiple times. Similarly, of all the negative reviews that I got, which product features have been used frequently to give reviews, and accordingly I can work on it and I can better the product or the services. So that's what we can do over here. Okay. And in case if I want to build this model, if I have to build this model, so what I can do here is I can simply go to in our lab, we have our lab open over here. I can start a new notebook. I have a data set over here, which I want to show you. This is what the data is. It tells me that there is a tweet ID. This is a Twitter data. It tells me there's a tweet ID, which is 1, 2, 3, 4, 5. And for each tweet, there is a sentiment which has been already registered, probably a manual approach where we have tagged all the sentiments, whether it's positive or negative. And these are the tweets which have been mentioned in the data set. So this is the first tweet, then second and third. And what you need to do is you need to analyze this data. You need to analyze this entire data, and you have to come up with a classification model, which tomorrow can take any tweet as an input, and can classify them as whether they are having positive sentiment or negative sentiment. Okay, so that's what the problem statement is. So you need to learn from this data how to classify a tweet into a positive sentiment or a negative sentiment in an automated fashion. So tomorrow, moment a tweet comes, you can get it belongs to positive sentiment. Okay, what are the keywords have been used? We can extract and we can create a nice dashboard on top of it, which explains that what has been mentioned in the given data. And for doing that, it's not a very difficult task to build something like this. All we need to know is how many times a particular word is happening in each of the review. And I can find out frequency of a particular word divided by total number of words, and that is called likelihood. And we will calculate likelihood for each word. And then we will apply our Neo Bayes algorithms. It will go like this. What is the probability that a tweet has a positive sentiment provided word good is there, provided word better is there, provided a word not is there, and so on. And we will calculate this conditional probability using the naive Bayes theorem that I was just talking about. We'll also calculate what is the probability that the same tweet can be having a negative sentiment, provided good is occurring in that, better is occurring in that, and not is occurring in that. And whichever probability is higher, I'll classify my tweet as per that particular class. So what we need to do here, we need to find out what is the likelihood of good. How do we define that? How many times good is appearing in all the positive sentiment data, and what is the total number of words which we have received so far among all the positive sentiment data set that has been given to us. Similarly, here I can calculate likelihood, apply naive Bayes, and the model will be in place. As simple as that. Okay, so this is what naive Bayes can do it for you. Now, in case if you're wondering how it is getting done, I can explain that one more time if you want. Here, I'm just going ahead and I'm applying my model. I want to apply my model on this. And some basic cleaning we do generally before building the model. Like, I don't need RT because this word has no impact on the sentiment, whether it's positive or negative, it doesn't matter. Similarly, the handles which are there, those handles are basically Twitter IDs, and that also does not impact whether the sentiment will be positive or negative. So some basic cleaning has to be done on this before we proceed and we build a model. So those cleaning, again, you can do in Python in a very simple step. You have certain functionalities which you can apply and you can take care of it. So we import a relevant library, and I can simply say here that define a cleaning function, which is generally taught to you in detail what we are doing over here. In case if you do not associate it, don't worry about it. This is just a cleaning that we can do over here if required. And then we write our statements which will clean these tweets. And with that clean data, we build the model. At the time, for the purpose of demo, I'm simply using the entire data without cleaning it. So what I need to do, I need to find how many times a word is appearing in this given tweets which we have. So I'm going to say here that CV is equal to count vectorizer. That's a functionality that we have in our Simplilearn. That's a machine learning library. And here I define this and I say that X is equal to CV dot, and I'll say fit on df dot text. Okay, so it will just find how many times a word is appearing over there, which we'll call it as X underscore bag of words. And this will be nothing but getting all the count of each word which is there. And with that, we can simply build the model. So now what we're going to do here is, I'm going to say here from Simplilearn. Okay, I need to define Y also. So the standard approach of model building is this. If you have been given data, like in this case, we have a single column, and with that we are doing feature extraction. But generally, like talk about credit card transaction is fraudulent or not. So we will have what was the amount of transaction, what time it has happened, okay, what was the mode of payment, what was the location. And along with that, I will have an outcome which is historically defined, that when these values were there, whether transaction was fraudulent or not, yes and no. And the standard procedure of building model is that you say that this is my X and this is my Y. We separate X and Y. X is my input, Y is my output that I want to map to. So here I'm saying my X value is My X value over here is this text values which were there, the tweets which were there, converted into a frequency representation. How many times a word is happening? That's my X. And my Y value would be NP. So what we need to do here is we need to define Y as this NP dot where if the sentiment is equal to positive, I'm going to denote that case as 1. And if it is no, then if it is negative, I'm going to denote that as 0. That's my Y value. So I define my X and Y value. That's a standard procedure. And then what we do is we take the data set, we make 2 partitions, we call it train and test. On the train data set, we build the model, and on test data set, we evaluate the model. Standard procedure for model building. Okay, so now what we are doing over here, I'm saying from Simplilearn dot model selection import train test split. I'll split the data into train and test. I'll simply say here I have X component for train and test. I have Y train and test. And this is equal to train test split X comma Y. And then we can build the model. So I'll say from sklearn dot new base import multinomial NB. I'll say my model, which can predict the values, is going to be this, and just train your model. And when we train the model, we simply say fit. Doesn't matter which model we are building. You simply say model dot fit. That's the same. This is the same function that we use across any kind of model we are using. And now our model is trained. Just matter of 4 or 5 lines, our model has been trained. So if you know the right model, if you know the concept, model building will not take much time, but data pre-processing takes a lot of time in certain cases. And also the fine-tuning of the model takes a lot of time. Now I can check how good my model is. On the data set on which it has been built, so I got 91% accuracy. Out of 100 cases, 91 of them is predicted correctly. Then I want to also check how my model is working out on the test data set. And model accuracy on the test is 83. So basically what is happening over here, my model performs very well on the data on which it has been built. That's my trained data. But its accuracy is not similar on an unseen data. And because the train score is higher than the test score, we say this phenomena as overfitting. And overfitting is a very common problem that you come across in any of the machine learning model. And now our focus should be that how do we take care of this overfitting? And for different models, there are different approaches. So I can work with some smoothing parameter over here. And probably if I clean the data properly, this overfitting will not happen, which I know because I have done this multiple times in the past. But this was just to give you a little overview over here. So here we got a model which has an accuracy of 91%. I want to predict any new tweet which is coming, whether it has a positive or a negative sentiment. Let's try and see if it's working well or not. So I can say here new tweet, and I'm simply writing a simple sentence over here. I'm going to say here a simple sentence. I'm writing here, not writing as a tweet and all. I'm simply saying here I got some new tweet, and I'll say np.array. And somebody said that movie was excellent, very good. That was the first tweet I got. This is just about some movie. And then I say, okay, I have another one. I have another one, which is say, it was very bad experience, something else. Okay, so I got here a tweet, which looks like this. And I want to apply my model on this. And this could be any new tweet which is coming, or it could be some other data where you want to see how the same model can work out on that or not. So all I have to do first, we have to use our count vectorizer to extract feature out of it. So I'm going to say here that, okay, new tweet underscore features, I would say, or probably I will say bag of words is equal to cv dot transform. And I'll say here new tweet. Okay, so that's what I'll do. So just a second, got stuck actually. Hold on a second, guys. Hold on a second. Just running.
It happens sometimes.
Yeah, no, it's just a problem with my connection, I think. Okay, over here. So what I'm doing over here is new tweet dot, and I'll say here tweet. Okay, so what we have here is a new data set which has these two reviews, and I want to apply my model on top of it. So then I'm creating bag of words for this tweet. Now every time I get a new data, I need to count how many times a word is appearing in the given tweet, and I need to map it to the original model. And now I can say model dot predict. I can say predict on this new tweet BOW. And it gives me a prediction as 0 and 0. It's just labeling both of them as a negative sentiment. So basically this it's predicting perfectly, but on this one it is not doing a good job. And as I mentioned that I have done this in the past multiple times. If I properly clean this data, which takes a little extra time because I need to process each sentence kind of a iterative way. So it takes a lot of time. So if I clean it properly, like I remove unnecessary words from here, I remove certain numbers, I remove symbols, and then when I build this model, this will be much accurate. But the idea here is to tell you that model building might take say 1 hour of time maximum, probably, because it's just bunch of code you are running. But fine-tuning of the model, which is solving this kind of issue, my model is not doing very well on the unseen data, so it is overfitted. Solving this is an iterative task. So it starts like this. You start with the data pre-processing. In general, I'm talking about where you clean the data. And I'm moving directly to data pre-processing, assuming you guys know that you start with a problem statement. What is the problem you're solving? Then you have data acquisition, and then you have data preparation. And that's the step I'm talking about. So once you do the data preparation, we'll have some transformation, some feature engineering, some feature selection, and then you reach the model building process. And once you build the model, you realize model is not very good. So what you do, you start fine-tuning it. Change the configuration of the model, it might become better. And if that also is not really working for you, you have to go back to this data preparation task. And this is a vicious cycle. You have to keep doing this n number of times until your model becomes really good on the trained data set as well as the test data set. So in practical scenario, what happens is that if I'm spending, and I'm telling you from my experience, if I'm spending 100 hours on a project, generally 60 to 70 hours will go in the data task, and it's an intensive task. Okay, so data task, and probably 10 to 15 hours you will spend in terms of training the model, and it depends on the model also. I might train a deep learning model, and deep learning model sometimes might take 4 hours to train a single instance. So that might be really time taking, but in general I'm talking about. And then another 20 to 30 hours, probably roughly I'm saying, okay, we'll go back and we will fine tune the model. So 30 to 15 hours will go into fine tuning of the model. So model building will be a very small task that we are talking about. You have to focus upon on data cleaning, feature engineering, feature processing. That's a very extensive task. So this is just to give you in a nutshell. The idea is this, that we have a lab where you get the presentation, which is dealt by the trainer over here, which I was explaining you. And then it will be taught to you. And parallelly there itself will provide you some data set and we'll start working on it. Generally, the notebooks that we create, it gets created with a lot of comments so that you understand what we are doing. Like here, I can make a comment over here as removing stop words, handles, symbols, and numbers. And that's what this function will do. So that tomorrow, when we share this notebook with you, or if you're making note parallelly, if you're doing with me parallelly, you will know why we are writing something and what we are doing with it. So every code will go like that, every line will go that. So like that. So basically, I'm saying here is that we'll explain you the concept entirely, and then we'll implement it on the data, and then probably we'll do a comprehensive case study on top of it. That's how it will go in the classroom. This was just to give a little perspective, and we had limited time. So I just explained to you what naive Bayes theorem is in a simple manner. A conditional probability given an event B has taken place, what is the probability A will take place? And that's what we calculate here. And it's an excellent model if you have a text classification in general. And if you have numerical data, then you go for a Gaussian naive Bayes, which is something similar, but it works with the numerical data rather than categorical data. So this is what in simple language, what naive Bayes is, and we just implement it. So Stuart, over to you now. I think we have done this one.
Had to find the unmute button here. All right, thank you very much, Amitendra. And let me go ahead and take back. Here we are. There we are. And we just did the lesson recap. So at this point, we're going to do questions and answers. And this was, the sessions in the boot camp typically last, live classes typically last 4 hours. So in today's sample class, we could cover only a small part of what you would be learning in one of the sessions. But I think this gives you a flavor for how the instruction works. So let me go ahead and start taking questions. If you have questions, put them into the Q&A function here. And please stay with us because we're going to talk a little bit about the bootcamp itself. But in the meantime, the first question is, will we get the recorded video? We will send you an email with a link to the recording of this session. So expect that after probably in about a day or so. Looking to see if there are other questions in the chat. Oops, wrong button. Pulling up the chat. Okay. So we have a question. This is a fairly advanced lesson for a newbie. Does the curriculum have a prerequisite? And this is a good point. As I showed you at the beginning, the curriculum, this is a lesson from the machine learning module, which is about the 5th in the series. So this will be farther along in the boot camp. But yes, there's going to be a whole bunch of preliminary material. Can you talk to that? Can you speak to that, Amitendra?
For the prerequisite?
Yeah, for how somebody would get to the
Sure.
point where they'd get to this lesson.
So it goes like this. You will have some pre-recorded videos, which works as a self-learning module. So before we start, we recommend that you go through that. And once we are in the classroom, by the time you reach to this particular module, you will be well accustomed with the data wrangling process, data cleaning, data preparation. So that will be covered entirely in detail, stepwise process. And then we reach over here. And even this model that we have been talking about will be dealt with a proper example in a little bit more detail, I would say. With the as Stuart mentioned, we'll have a 4-hour session rather than 1-hour session like we are having at the moment. So there will be a prerequisite, and we'll make sure that once you come to the live classroom, if you have any kind of doubts from the pre-recorded videos that you have to go through, that will be dealt first. Foundation will be created, and then only you will move to this particular part. That's how it goes.
Okay. Mohammed asks what language you are using in the coding example.
Language was Python. We were using Python over here, but the good thing about these algorithms are that it doesn't matter which platform you use, you will get the same result. It's just that Python is the most sought after language when it comes to machine learning. So we are relying on that.
And one of the things that goes back to the prerequisite question is that you notice, or you may have noted in the curriculum, that a couple of the modules of the curriculum focus on training you in Python and in applications of Python for machine learning. So if you come in without a background in programming, you'll still be able to keep up with the course and get up to speed. So, so Aaron asks if data cleaning is. I'll read it literally. I have a doubt that how to clean up the data like @ is simple and from the data. So I mean, I think he's asking about the actual technique for removing things like
Sure.
the user handles.
Sure. And one more question in addition to that I see, which is similar to it, Stuart, if I may. The question is, before building a model as current example, we need to clean data. Instead of cleaning, if you scale the data, we'll give a proper accuracy score. So I'll tell you this, scaling will work only if you have continuous numerical data. This is a text data. So scaling is normalization is done in a different way. We go for a TF-IDF score instead of a simple frequency. But if you have to clean the data, that's a separate process. Scaling is separate. You cannot say that if I'll just scale it, it will become better. It doesn't happen that way. Cleaning is a more robust task, which has a number of steps that you have to perform. And on the other hand, when you're talking about the question was that what tools, techniques we can use for cleaning the data. There are a number of things that you have to go through first on the data before reach to the model stage. So it could be on a structured data. It could be as simple as missing values or outliers, or probably feature extraction you are doing, or probably you're doing feature engineering. So a lot of things happen at the data level, including the data cleaning and all.
Thank you. Okay. What is the use of the RE library? Or
That's a regex library that is for working with the text data. If you want to, suppose, substitute certain text values in a given sentence, you can use re, and it is quite intuitive. It works with a pattern. So you might say that any number you find, replace it with blank. Any symbol you find, replace it blank. Or you can say that if a word starts with at the rate, and it doesn't matter what's the length of the word, if it starts with at the rate, remove it. So all those kind of processing, when it's required, we can use this library. RE stands for regex. It is also used for information extraction. Pretty useful library.
Okay. Projecta asks about techniques for dealing with overfitting.
Different model will have different ways of doing it. So like if I'm doing, suppose, decision tree, overfitting can be taken care by pruning of the trees. Like I can work on the depth of the tree. I can work with the split of the tree, the Gini values. Or if I'm doing, suppose, support vector machines, then I have their parameter C, I have parameter gamma, which I need to manually configure. Similarly, if I go to deep learning, I will have number of layers, number of nodes, the learning rate. So different models will have different ways of handling the overfitting problem. And that's where people should focus upon also. Learning a model is not sufficient. You have to learn how to fine tune it. And that's where taking care of overfitting will come. And every model will have its own way of dealing with it.
Okay, thank you. Saurav would like a reminder of where naive Bayes is used and what its limitations are.
Sure. Naive Bayes is generally used for text classification. It doesn't mean that we cannot apply on a structured data, numerical data, but generally we use for text classification. It works well. And for numerical data, we have better model than this. Assumptions are that it's called naive because presence of, think about email. When I'm calculating the probability, it is not bothered about presence of other words. It just focuses on one word at a time. So they are very naive. So the idea is this, that assumption is this, that these features are totally independent of each other. And wherever this kind of situation is there, we can use naive Bayes. And as I said, use it for text classification, gives pretty good result.
We have just a few more questions here. So Harish asked, does underfitting mean that the model is accurate?
Underfitting means model has a low score on the data on which it has been built, which is trained data, but it has a relatively higher score on unseen data, which is the test data. It means the data split is not good. You have to reshuffle the data, split it again, or probably add more data points to your training data. It will be taken care. Underfitting is not a big challenge.
Okay. We have a question from Navish, who asks, he's trying to learn about swarm intelligence. Will that covered in the bootcamp?
No, we are not doing that actually. Like that's a very niche and specific area, but this is the building block for that. Once you go through these techniques, then probably you can start building knowledge on that as well.
Thank you. And she asked a different question. How difficult is it to train with image data rather than verbal or numeric?
Okay, there was one question earlier also on image classification, which I missed out. So let me tell you, image data, when we work with, we have something called convolutional neural network, which has been designed to extract features from the images and then learn from it and do the classification as well. That gives a pretty good result and has become more or less a very standard model for doing any kind of image classification or object detection. In fact, you also get a lot of pre-trained CNN, which you can directly apply on your problem statement. The idea there would be like, if I'm doing image classification, suppose 2 classes. For each class, probably I need 1,000 images a piece. And then I can build a network in, say, if everything is up to the level, then it doesn't take much time. Probably an hour or 2 is sufficient if you have good machine. But the problem will happen when you have certain classification to be done, which is very complex. Like it could be finding any kind of error in a fabric actually. So that will be very, very minute, and you need to build really deep networks. So that might take time. So sometimes you might have a problem where you're training it for 3-4 hours also. And after that, you realize that model has overfitted. So another 3-4 hours will go for every iteration that you are running. So that takes time. And that's why we need good machines for that, GPUs and everything.
Okay. And we had several questions here about dealing with overfitting and underfitting, which is something that you'll learn in the course. But we've covered a little bit of that in the sample lesson, and we will be sending a link to this recording so that you'll be able to review what Amitendra spoke about. We also have a question, and we'll get into this interesting question, which is what is the best way for a developer to get from beginner to advanced field of machine learning and data science?
Beginners to advanced starts with the fundamentals of entirely machine learning. Start with the basic algorithms, master them. And what we do generally is we give you a lot of case studies to work upon on each module. And we tell you what are the advantages, disadvantages of a model, how do you fine tune it further, and then what will be going forward you have to do. So start with the simple linear models, then start with the non-linear models, and gradually you move towards the deep learning. That's what the process would be. And remember, these algorithms would be based on certain mathematical optimization algorithms. So some mathematical intuition will also be required, which generally we deal in the classroom. We give you the entire mathematical intuition, how it works. So I would say start with vector algebra at a very basic level, and then gradually move towards your machine learning algorithm. In fact, applied data science with Python, which is a part of this entire course curriculum, deals with vector algebra. It deals with your calculus. It talks about integral differential calculus that we have to use in our models. So that's how you should go about in general.
Okay. And I want to take one last question because I find it interesting, which is from Mohammed, which he works in sensors in remote health and wants to classify the sensed information to determine if it's faulty or not. So what type of classification model applies in that kind of problem?
Okay, reading the statement that you have mentioned, Mohammed, it looks like an imbalanced data. Imbalanced data is such where you will have a lot of cases where there will be no fault and only few cases which will have fault. So it becomes a little more trickier problem because you do not have ample example for one of the class. So in this situation, we try multiple models to start with. We also try stacked models, like multiple model you stack into a single entity. We also see how to take your imbalance aspect of it, how to penalize any wrong predictions which are happening. So this is one part. And if it doesn't work that way also, then we go to anomaly detection. Like anomaly detection will try and understand what kind of anomalies are there in the data, and those anomalies could lead to identifying a faulty class that you are looking. So depends on the data, but looking at it, I feel it's an imbalanced data problem that you will come across.
Okay. Do you mind if we take one or two more?
Yeah, go ahead.
Okay. Rashid asks if you need a better CPU when you're training a text data, or do you use a GPU? And just as a preliminary for this course, everything is done on the learning management system. So you have a virtual machine assigned that you don't have to worry about your own setup at home. But in the general case, if you were setting up a machine learning system, would you focus on the CPU or use a GPU as a different
depends on the sorry, Stuart, you were saying something.
No, go ahead.
I'm saying depends on the problem. If you have relatively smaller set of data, you can get away with CPU. GPU is required if the data size is huge and even the model that you are using is really complex model with deep layers inside it. So then it becomes difficult to train it on over the CPU in the prescribed time. And that's where GPU comes into the picture. We can parallelize the training. Like by the time we finish one iteration with the help of GPU, we can have multiple threads going on. So depends on the situation. Like so far, if you ask me, in last few years, we have been exclusively working on the image classification and object detection problem. So we have been using machines which has GPU support to it, because we have to reduce the training time even for the NLP processes. But some of the machine learning model that we have built could be well dealt with the CPU itself. So it depends on the situation.
Okay, thanks. And the last question from Aaron, who has asked a couple of times about the problem of dealing with 25,000 rows of data, and how would you tackle that in terms of selecting what to use for test data and what to use for training data?
25,000 data points. It's not much in terms of size. In a sense, you will be easily handling it. And generally, we want to keep a higher proportion of data for the training purpose. So 70-80%. If you ask me, 25,000 data points, go with 75% into train, 25% to test, or probably you can do a k-fold cross validation also, where you can actually put them into multiple groups, and with each group you train one by one. So that's a different process of it, but that wouldn't be a problem. 25,000 data points is sufficient, and make a 75-25 split, it will work.
Thanks very much. Okay, so that covers the questions. We're at toward the end of our session here. So what I'm going to do is return to and mention the boot camp from which this lesson was drawn. This is a 6-month fully online program, and it's designed for people who are working professionals. So you only have to dedicate about 10 hours per week. It includes, as I mentioned, live classes, generally on the weekends. Not every module in the curriculum has live classes, but for the ones that do, you would end up with 4 hours on Saturday, 4 hours on Sunday, and that would be the same kind of live instruction that you got a sample of today, with the integrated labs, with the going through the exercises, and you'd have your own lab and project platform to do the work on, so that you could replicate what Amitendra and the other instructors are teaching you, and do the exercises yourself so that you get hands-on learning. You also, through that process, build up a portfolio of examples of experience that you show off potential future employers. And again, the rest of the time, as Amitendra said, when you're working on projects, when you're working on or looking at support materials, ebooks, and videos, you do that on your own time, anytime, 24/7, so that you can fit that into whatever schedule you have available. So somebody asked about prerequisites. You only need a basic understanding of mathematics and programming concepts. You do have to have a bachelor's. This is the boot camp. Actually, you don't have to have a bachelor's degree. And then 2 or more years of work experience is preferred, but not required. So, and we also provide career assistance after you graduate from the boot camp. So for an additional 6 months, you get help with exclusive job portal, resume review, and rewrite service, and one-on-one interview prep. So all of that's in the program. So I'm going to ask a series of quick questions, if I may. First one is, oops, sorry, to move on past that one. Let's ask this first question. If you're watching on a streaming service, you can put A, B, C, or D in your comments, but this one is, how much experience do you have? I'll close this in about 3 seconds. And here we go. So about a third of our audience are people who are currently students. Again, this is the Caltech Boot Camp. The actual requirement for this is a high school diploma, not a bachelor's degree. So this is open to pretty much everybody who's here today. Show you the result here. And next I'm going to ask two questions, one after the other. First one is, are you interested in enrolling in the program? Based on what you've seen in this sample lesson, what we've talked about today. And this is not a commitment. You don't have to enroll if you answer yes, but we're just curious to know, could be interested. I'll leave this open for another 3 seconds. 2, 1. About 2/3 of the audience are interested in that. So I will ask the other question here. How soon would you see yourself, for those of you who answered yes, how soon did you see yourself enrolling? And we do cohorts of this program fairly much on an every month basis. So there's next cohort starting pretty quickly after this session. Again, I'll close this in 3, 2, 1. And I'm looking at about half of the audience are interested in joining either immediately or fairly soon thereafter. So again, I'll show that to you. And lastly, if you would like to get a certificate for attending this session, this sample lesson today, just a proof of attendance, it doesn't certify anything else except proof of attendance. Or if you would like us to reach out to you and answer questions, help you with enrollment, I do want to mention that there will be a discount offer and you'll be able to ask about the price of the program. You'll get a $500 discount from the program cost if you mention that you attended this webinar. So we'll be sending all that information in the follow-up email as well. So let me launch this question. Are you interested in having us reach out, or would you like to get a proof of attendance for the session here? And all right, and I'll end the poll. About 55% of our audience said that they would like us to reach out, which we will do after this session. So thank you all very much. And I want to thank Amitendra for attending. I'm going to put into the chat box right now the email address that you see, along with the URL for the program web page. And what you'll be able to do there is check the course price and the detailed curriculum, and get more information, including testimonials from people who've taken the course. And that's in the chat box right now. So I want to thank everybody for being here, and thanks again to Amitendra for being so generous with your time and your knowledge.
Thank you, Stuart.
Okay, and we'll see you all. We hope to welcome you into the Simply Learning Caltech learning community. So again, that ends our webinar today.